Hello everyone, welcome to the Keshara Wickramasinghe YouTube channel. Alright, so today I'm going to teach you the EASA Module 1 Mathematics lesson number 2 Algebra. Right, so if you are new for this video, for this lesson, first go and see the first lesson I did regarding the arithmetics in the above card, right? So you can check the lesson through the above card. All right, so let's go to the today lesson. So today lessons contain is 2.1 introductions. Under introductions, operations and basic law we will going to discuss, and the equations. Under equations, solving linear equations and transpositions in equations, and construction of equation under transposition in equations, and then simultaneous equations and quadratic equations. All right, so now let's go to discuss the introduction. All right, so introduction. The algebra is designed to make matters simple and clear. All right, for instance, let's say we need to calculate the amount of carpet that will be required to cover the floor of a room that is 5 meters long and 3 meters wide. Nobody would hesitate to arrive to the conclusion that the answer is 15 square meters. However, that solution is associated with particular area. The area is calculated by multiplying length by width. So area can be calculated by multiplying the length by the width or breadth according to the standard response or breadth. All right, so you can see these equations, and then however it is simpler to write A for area, length for L for length, and B for breadth, where A, L, and B stand for area, length, and breadth respectively. This is the basic of algebra, where each letter stands for a variable and only when a certain value is present. All right. Therefore, it is crucial to explain what the letters in an algebraic expressions mean. X and Y are two letters that are frequently used, but other letters include G for accelerations due to gravity, R for density, and so on. This is the purpose of algebraic notations. All right. Okay. Yeah. So let's go to the operations on the introduction. The fundamental of algebraic operations are the same as when using the numbers, right? Algebraic operations are very same as using the numbers, right? So example, adding A and B, we can written by A plus B. So subtracting A and B is written by A minus B. Multiplying A and B is written by AB. Right, so dividing by B is written by A divided by B, and squaring we can A is A to the power 2, right? So this is the normal law. So we are not limited to using only two letters, right? So example, multiplying by B and divided by C becomes logically A into B divided by C, right? So we can include three numbers also. So note also that the order in which letters appear is basically unimportant, right? Example, A into B into C into D, A, B, C, D. So we can make it order as B, D, A, C, C, A, B, D like this, right? Example, 3 into 4 is obviously the same as 4 into 3, right? So it means we don't care about the order, right? All right, so when multiplying two symbols such as X and Y, we do not need to use the multiplication sign. The result is the same if you multiply a number by a symbol, right? Example, see 3 into Y, 4 into Z, S into P, A into B, Y into Z into M. So in these situations, we don't need to use the multiplication symbol. Right, so we just write directly, like can be written as 3y 4z sp ab and yzm respectively instead of the multiplication sign. All right, so like terms, now we're going to learn the like terms. Like terms are terms comprised of the same algebraic quantity. This is important. 7x, 5x, and minus 3x are all terms containing x, right? So these are the example, right? So 7a, 4b, 3a, and minus 6b can be split into two groups of like terms, right? In this four algebraic expressions, like 7a, 4b, 3a, minus b. In here you can see two kind of like terms. What is the first one? A, and second one is b, right? So 7a and 3a and 4b and minus b. If like terms containing numerical coefficients, they can be simplified. Example, 7x plus 5x minus 3x. So we can simplify it by 7 plus 5 minus 3 under the brackets and x, so equal 9x, right? So this is the, so why? Because x is the like term for these three expressions, right? All right, so example 7a, 3a, 4b, 6b, you can make it as 7a plus 3a, 10a minus 4b minus 2b. All right, so terms like ab plus cb minus db may be simplified as a plus c minus d into b, right? B is common factor of three terms. All right. Okay, so the ability to factor is quite useful when working with algebraic terms, remember, and formulas. Similar to this, it is possible to simplify calculations by dividing the numerator and denominator by the same term. Example, by cancelling the top and the bottom, we can cancel. See, 3a squared b divided by 6ab squared, we can write 3 double a into a b and 6a b into b. So in this situation, we can cancel b to b, a to a. So the answer is answer would be here 3, right? 3a divided by no, then we can cut 3 is 1. How many 3s for 2? 2. So how many 3s for 6? 2. So then 1 upon 2. So we can say a divided by 2b, right? Okay, so now we'll go into the basic clause. Algebra follows the same procedure rules as arithmetic, named as BODMAS. In the previous lesson, I teach you how to use the BODMAS rule in the arithmetic, right? So algebra also follow the same procedure. Brackets appear more frequently in the algebra and are only removed when there is a strong reason to do so, such as when further operations result is more simplification. All right, so example 3x plus 7y minus 4x plus 3y equals, so then we can simplify the brackets, like see 3x plus 7y minus 4x and minus into plus minus 3y. Example 3x minus 4x plus 7y minus 3y, example plus 4y. So this is the solved equation. When brackets are removed, all terms inside the brackets are multiplied by what is immediately outside the bracket. Okay, so what is the immediately outside the brackets? We have to multiply when there is a bracket. The fundamental process is as follows, right? Example a inside the brackets x plus y, so then we have to multiply by x plus y by a, so ax plus ay. Example a plus b in inside the bracket x plus y, so then we have to multiply x plus y by a plus b, so then ax right, here is yeah, both x and y are multiplied by b. Sorry, no, in this situation I'm wrong, I'm sorry. In this situation, x plus y, we have to multiply by what is the immediate multiplied by what is immediately outside the bracket. So what is the letter which is immediately outside the bracket? It is b. So then we have to multiply x plus y by b, so then a plus bx plus by, both x and y are multiplied by b, right? So the next one, a plus b and x plus y, so these two are brackets, right? So then we have to multiply x plus y by a plus b. Then when we, how we multiply, a into x plus a into y plus b into x plus b into y, right? So this is the when we simplify these algebraic expressions, this is the way answer is come. So ax plus ay plus bx plus by, x and y are multiplied by a plus b. All right, so then next one, a plus b squared. So then a plus b squared, we can write by a plus b plus a plus b inside the bracket. So then a into a plus a b, a into b plus b into a plus b into b. So then a squared plus ab plus ab plus b squared. So then we can write as a squared plus 2ab plus b squared. All right. Okay, so now let's go to examine each term to seek for common factors while factorizing. The common factors of a squared b and minus 2ab squared are a and b. They appear in the both. Hence, a squared b minus 2ab squared can be written as, we can take it out a and b. So when we take it out ab outside, then we can say, we can keep out, when we take it out ab outside, then there is another a. So a minus 2b. So this is the equation AB. If we take it out AB, so then A minus 2b. AB and 2AB, AB and A minus 2b are both factors of the complete expression A squared B and minus 2AB squared. Has already stated, the ability to see factors is an assessed. Okay. Example, ax plus bx plus ay plus by. So then we can take it out x. When we take it out x in these two things, we can take it out x. So then a plus b. Plus, when we take it out y, we can say a plus b. So then we can say x plus y. So because a plus b is common, so x plus y into a plus b. Or ax plus y plus bx plus y. So then x plus y or a plus b. This is the two terms how to see the factors in the in some equations, right? So algebra can be extended to include fractions. Example, a divided by b plus c divided by d. So then we can make a common denominator b into d. So then a divided by a into d, ad plus cb divided by bd. So bd is the least common denominator, ad plus cb is the numerator. All right. So I teach you about the least common denominator in the previous lesson. Now we'll go to the 2.2 equations. An equation is the statement a minus 4 equal 5. We are stating that an unknown quantity minus a equal 5, minus 4 equal 5. It doesn't take a genius to figure out that the unknown quantity in this case is 9, right? See, a equal 4, a minus 4 equal 5. No, so you can easily can guess the answer a equal for 9. Why? 9 minus 4 equal 5, right? So, and there is only one correct value. Guesswork or eliminations can be used to calculate the value of a. Solving the equations refers to the process of determining that a equal 9. All right. So solving linear equations. Now we'll go into solving the linear equations. A linear equation is one that simply contains the first power of an unknown quantity. Right, example, here you can see two linear equations. Example, 5y minus 5 equal 3y plus 9. Or 5 bracket inside the brackets m minus 2 equal 15. The way a linear equations looks can change when it is solved. Right? In the first equation, for instance, 5y minus 3y equal 9 plus 5. 9 plus 5. So how we did it? 5y, we will take 3y into this side and plus y we send to this side. So then 5y, when the plus 3y, when it's come to this side, is take minus 3y. So then if we send 5 plus minus 5 to this side, then it will become plus y. So then 5y minus 3y equal 9 plus 5. And in the second, 5m minus 5 into 2, 10 equal 15 respectively. Although they both differ from the original form, they are the same since equality has been maintained. General rule for all equation is whatever you do to one side of the equation, it means if you do something to one side of the equation, you must do the same to the other side. So the same action you have to do, right? Example, if you minus from this side, you have to minus the same number from this side. All right. Okay. So the next one, by practice, each side of the equations is refers to as the left hand side or the right hand side, right? This is the left hand side or the right hand side. All right. Okay. So then 2.2.1.1 equations requiring multiplications or divisions. See, solve the equations x divided by 5 equal 4. So let's see how to solve these equations. If we multiply both sides by 5, we get x divided by 5 into 5 equal 4 into 5. See, so how now in these equations we have to solve the x. So solve the x, first we have to remove the denominator. So how we remove the denominator? We have to multiply by 5, right? So as the previous one I said, whatever you do one side of the equations, you must do the same thing to the other side. So if we multiply here by 5, and then we have to multiply right side also by 5. So this is the way I do. So the solution is x equal 20. So the solve the equation 4b equal 20. So dividing both sides by 4 to get b answer. So how to get the b answer? We have to divide it by 4. As we said in the previous rule, we have to divide this side also by 4. So then the b is 5. Then equations requiring addition or subtraction. The simplest type of linear equation of this type is x minus 6 equal 9. To solve all equations, we must manipulate the equations to get the unknown on one side and the known value on the other side. In this case, we must eliminate the value of minus 6 from the left-hand side. This can be done by adding 6 to the left-hand side, but we must also add 6 to the right-hand side. So the equations become x minus 6 plus 6 equal 9 plus 6. So when the simplify the equations to obtain x equal 9 plus 6 equal 15. So the solution is x equal 15. So here the x equal 15. A simpler way of solving this type of equation is to switch values from one side to another. When we do this, we must, however, change the sign. Example, solve y plus 4 equal 14. If we switch the plus 4 to the right hand side and change the sign, it becomes y equal 14 minus 4. So the solution is solution is y equal 10. All right. So now let's go to the equations containing unknown on both sides. All right. So in equations of this type, we should group the unknown quantities on one side and the other terms on the other side. All right. So for example, solve 8y plus 4 equal 5y plus 22. Right. Okay. So if we subtract 4 from both sides and also subtract 5y from both sides, we will get 3y equal 80. Right. It means we have to subtract minus 4 from both sides and we have to subtract minus 5y from both sides. So then we can get 3y equal 80. The solution can then be obtained by dividing each side by 3. Right. So then how to get the y? So then we have to divide the both side by 3. So then if we divide the both side by 3, this will become, right? See, so then y should be equal 6. Note, as in all cases of solving equations, we can and should check our solution is correct by substituting the solution in the original equations, right? After we get the answer, we have to put this value to the equation and then we have to check it's correct or not, right? So left hand side, if you put to the left hand side, 8 into y equals 6. So 8 into 6 plus y equal 5 into 6 plus x into, when we go into left hand side, then 8 into y 6 plus 4 equal 48 plus 4 equal 52, and then right side, if you go into right side, 5 into 6 plus 22 equal 20 plus 22 equal 50. So both sides are same, these equations will be same and the values are also correct. So now let's go to the equations containing brackets. The first step is to remove the brackets and then solve as normal, right? The first step is we have to remove the brackets. See, 3 inside the brackets, 2y plus 3 equal 21. So the first expand the brackets to obtain. So then when we expand the brackets to 3 into 2, 6y plus 3 into 3, 9 equal 21. Then subtract 9 from both sides. Then we have to subtract 9. So then 6y equal 12. Then divide both sides by 6. The solution is y equal 2. To check the solution is correct, we substitute y equal 2 in the original equations. Left hand side, so then we have to substitute y 2 as for the y. So then if we go to the left, if we get the left side, then 3 into 2 into y is 2 into plus 3 equal 3 into 4 plus 3 equal 3 into 7 is 21. So the right side also 21. So the answer is correct. So now equations containing fractions. In this case, we must multiply each term by the least common multiple of the denominator, right? Example, y divided by 4 plus 3 divided by 5 equal 3y divided by 2 minus 2. So in these equations, the least common multiple of the denominators are 4, 5, and 2. Is then with least common denominator, I teach you how to find the least common denominator in the previous lesson. So in this situation, least common denominator is 20. So we must multiply each term the equations by 20. So then we have to multiply each term by the 20. So then y divided by 4 into 20 plus 3 upon y divided by 4 into 20 and plus 3 upon 5 into 20 equal 3y divided by 2 into 20 minus 2 into 20. So the answer is 5y plus 12 equal 30y minus 40. Then 5y minus 30y equal minus 40 minus 12. So the minus 25y equal minus 52. Note in this case, we have negative values on both sides. If we swap them around and change the signs, swap the left hand side and right hand side, so then we have to swap. So then 52 equal 25y, right? Now transposition of equations. Consider an equations formula that is provided, right? So 6a plus 11 equal to 25 minus a. This equations has the letter a, right? The one algebraic variable. Consider an equation as a balanced statement. In this case, 25 minus a on the right hand balance 6a plus 11 on the left hand side. All right. There is only one numerical value that can result in the balance because there is only one equation and one unknown. It is what? It is possible to separate the letter A on the left side of the equations and balance it with a real number on the right side of the equations by rearranging, transposing in the word. This will then represent A's special value. All right. All right, see in this equation 6a plus 11 minus 25 minus a. So we will see how to solve this one. So to remove a on the right hand side, we must add a to both sides. To remove a from the right hand side, we have to add both sides the a. So then 6a plus 11 plus a equal 25 minus a plus a. So therefore the answer is 7a. 6a plus a plus 7 6a plus a equals 7a plus 11 equal 25. To remove plus 11, we must subtract 11 from both sides. Then 7a plus 11 minus 11 equal 25 minus 11. So the answer should be 7a equal 14. And if 7a equal 14, then a is 2. We have found that a equal 2. This is unique value which satisfies 6a plus 11 equal 25 minus a. Read the equations to notice how we were able to isolate the necessary term a on one side also. Keep in mind that whenever you change one side of an equation, you must also change the other side in order to keep the equations in balance. All right. This is the main purpose of transposition. Right, rearranging equations-based formulas help us to evaluate a specific numerical value for one unknown quantity if the other numerical values are unknown. One thing to remember is that only when all the other values are known can an unknown quantity be found. This is what is meant by solving an equations. All right. Okay, so now let's go to the construction of an equation. As was already said, maths is a tool used by engineers throughout the design phase. A component or mechanism is designed, therefore it is made of metal or plastic, or when it is created on a paper. With his understanding of the materials and their strength, the design engineer can hopefully make it strong enough by calculation. He employs equations and formulas. All right. He must assign letters to various variables or known quantities in order to accomplish this. He can then use the letters in a reasonable statement about the situations to create a formula or equation. He considers the situations before making the statement. All right. So example 1, think of a number, double it, add 6 and divide the result by 3. What is the answer? Right? Okay. So let's the number you think of be a. Doubling this number gives 2a. If 6 is then added, we have 2a plus 6, which must then be divided by 3, making the answer is equal to a plus 6 divided by 3. This formula can be used to calculate the answer no matter what number you think of. All right. Okay, now we'll go to the example number 2. If one side of a rectangular field is twice as long as the other, the short side is 100 meters, calculate the area of the field. So let's see how to imagine how to construct equations. So let the short side of the field will be F. The long side of therefore 2L into L, 2 into L or 2L. To calculate the area, we multiply one side by the other. So area equal 2L into L equal 2L squared, where L equal 100 meters. So area is 2 into 100 meters squared. So 20,000 meters square meters. All right. All right, so now simultaneous equations. We'll go to simultaneous equations. To take account the formula 4x minus 3y equal 1, one equations cannot be solved to get a single solution for x and y since it contains two unknown x and y. There are an endless variety of x values that have equivalent y values. All right. So then if x equal 4, then y equal 5. If x equal 7, then y equal 9. If x equal 1, and y equal 1. However, if a second equations, for instance, x plus 3y equal 19 x's, these two equations can be evaluated simultaneously to get a single answer for each variable and x and y. The procedure is simple and consists of changing the equations while maintaining the equalities. All right. So here is 4x minus 3y equal 1. This is the first equation, and second one, x plus 3y equal 19, second equation. So the method of solution of all simultaneous equations 2, this is the way how to solve the simultaneous equation. So let's read. First, manipulate one or both of the equations so that the coefficient of one of the unknown is the same in both the equations. Second one, then add or subtract one of the equations from the other to produce a third equation with only one unknown, the other having become 0. Solve the new equations to find the unknown. Put the solution into one of the original equations to find the other unknown. Put both solutions into the equations not used in the stage above to check your answers. All right, so let's see how to solve these equations using the two equations above as an example. So let's see how to solve these equations. We do not need to manipulate either of the equations because the coefficients of the y is the same in the both equations. Therefore, we can eliminate y value simply by adding two equations. All right. See, in here there is the same in the equation number 1 also have 3y minus 3y, and equation number 2 also have plus 3y. So we can remove 3y by simply adding 1 and 2. All right. So then when we add 1 and 2, we will get 5x equal 20. So the x equal 4. If we then substitute x equal 4 in the second equations, we get 4 plus 3y equal 19. So 3y equal 19 minus 4, so 15. So y equal 5. Our solutions are x equal 4 and y equal 5. So let's see an example. Example number 1, 2x plus 3y equal 8, number 1 equation, and 3x plus 5y equal 11 is number 2 equation. Multiply equation 1 by the coefficient of x in equation number 2. So why? Because in here, if we the equations are different, right? So the numbers are different. So then we have to make it one same number. So if we multiply 1 by 3, then we can 1 by if we multiply equation 1 by coefficient of x in the equation 2, right? So the first one we have to do is we have to multiply 2x. It means number 1 we have to multiply by the coefficient of x in the second equations, right? So then 2x plus 3y equal to 8, we have to multiply by 3, and the second multiply equation 2 by coefficient of x in the equation number. So then this one number 2 equation we have to multiply by 2. So then if we do this one, then we will get 6x plus 9y equal 24, and then 6x plus 10y equal 22. Why? We have to multiply by this one, this equation we have to multiply by 3. So then 3 into 2 is 6x plus 3 into 3, 9y equal 24. And when we multiply this one by 2, then 3 into 2 is 6x plus 5 into 2 is 10y equal 22. Okay, this is the number 3 and number 4 equations. Subtract equation 4 from y, 3 from y, because y we have to subtract this one from this one, right? So then we have to remove 6y. See, when we subtract 3 from 4, then the answer is 0, x equal 1, y equal 2. Then this is so the minus y equal 2. So then y equal minus 2. Substitute y equal minus 2 in either equations 1 or 2 to solve for the x. I have selected 1. So right, then I selected number 1. So then if we substitute y minus 2 for the y, so 2x equal plus 3 into minus 2 equal to 8. Therefore 2x equal 14 and x equals 7. All right. Check your answers by substituting both values in equations 2. Do not use equation 1 because it will not highlight an error. If you had used equations 2 to fix x, then check should be carried using the equations. All right. 3x plus 5y equal 11. 3 into 7 plus 5 into minus 2 equal 11. Therefore 21 plus minus 10 equal 11. Correct. All right. So then the equation, the answers are correct. So now let's go to the quadratic equations. Any equation of the form of y equal a squared, ax squared plus bx plus c, where a, b, and c are numbers, is known as quadratic equations, right? Remember this one. An equation of this type will produce a curve called parabola. These are the parabolas. These are the called parabolas. The actual value for coefficients A, B, and C will determine the exact shape and position of the curve, right? So see the actual value of coefficients A, B, and C. The actual value of coefficients will determine the exact shape and the position where is situated and the exact shape of the parabola or a curve. It will be noted that one of the curves cut the x-axis at point P and S. P and S are known as the roots of the equations. Alternately, P and S are the values of x which satisfy the conditions y equal ax squared plus bx plus c equals 0. It can be shown that the roots are found to be equal to. These equations gives two values, one for P and the other for S. So we can use the following equation also to find the x. C minus b plus or minus b squared minus 4ac under square root plus divide by 2a. So this is the same equations. We can use the above equations to find the value of P and S. So find the roots of, let's see, we will get the value for the A, B, and C. So y equals 6x squared minus 5x minus 6. So then A is 6, B is minus 5, C is minus 6. So A is minus B. So then minus B is what? Minus 5 plus or minus b squared, so minus 5 into squared minus 4 into 6 minus 6 divided by 2 6. So when we calculate like this, in this case point PS is minus 2 upon 3 and 1 and 1/2. Right, these are the 2 points, right? P and S. All right, so this is the end of algebra. So I think you have got some knowledge about the algebra. So thank you for joining for this lesson. And if you missed the first lesson, please click the above card and go to the first lesson and learn about the arithmetic. And in the next lesson, I will going to teach you the numbers, right? Lesson number 3 in module 1 mathematics. So don't forget to subscribe my channel, and please like this. If you like this video, please like the video, and also share this video for your friends and for your relatives, and it will be useful for them. All right, so that's all for today, and we will meet on next video. Thank you very much.